Good morning, students. In the journey of explaining the lesson, is a matter around us pure. Once again, I am going to recapitulate pure substance. What is pure substance? The matter or any substance which is made up of same kind of particles. And moreover, pure substance can be classified into number 1 element and number 2 compound. What is element? Element is the pure substance made up of same kind of atoms. Example iron, gold and silver. These are the best examples. And compounds. What are the compounds? Compounds are the pure substances made up of same kind of molecules. Example carbon dioxide, ammonia and water. And finally, the flow chart. Matter can be divided pure substance and impure substance. Pure is classified into elements and compounds. And a mixture is the best example of impure substance and divided into homogeneous and heterogeneous. And further classification, solution is homogeneous, whereas suspension and collided particles are heterogeneous mixture. And mixture means it contains more than one pure substance. The mixture can be classified into homogeneous mixture and heterogeneous mixture. And a homogeneous mixture having uniform composition throughout, whereas heterogeneous mixture consisting of non-uniform composition throughout. Salt and water is the best example of homogeneous mixture, and sand and water is the best example of heterogeneous mixture. Today I am going to focus the properties related to true solution, colloidal solution, suspension, which are very important. True solution. True solution is nothing but homogeneous solution. And examples of true solution, salt and water, sugar and water. Salt dissolved in water, sugar dissolved in the water is the best example of homogeneous mixture. And colloidal solution. It is heterogeneous mixture, no doubt, but appears as homogeneous mixture. Examples of colloidal solution, egg albumin, milk, hemoglobin in the blood, and smog, smoke plus fog. These are the best examples of it is not only this one, shaving cream. Suspension, it is a purely heterogeneous mixture. An example, sand and water, oil and water. And size of the particles. The size of the particles for true solution less than 10 power minus 7 centimeters, whereas colloidal solution the particle size is in between 10 power minus 4 centimeters to 10 power minus 7 centimeters. And finally, the size of the particles in suspension more than of 10 power minus 4 centimeters. So I have introduced the centimeter language. Now, today I am going to introduce new term, that is Tyndall effect. What is Tyndall effect? Whenever light passes through one particular medium, here light is scattered by some particles in that medium, then the path of light is visible. This is called Tyndall effect or Tyndall phenomena. It shows scattering of light. Simply, I'm saying to you, when a beam of light passing through any particular medium, the path of light should be visible. So, this condition phenomena can be called as a Tyndall effect. See, light is passing through solution and collided solution. But here, in the collided particles, the path of light is visible. So, in the case of collided particles, scattering of light possible. So, Tyndall effect. For true solution, we can say that no Tyndall effect due to very less size of the particles. So, light can pass very freely. In the case of colloidal particles, there is scattering of beam of light occurs. So, whenever light passes through collided particles, the path of light is visible due to medium size of the particles. So, we can say that colloidal solution shows Tyndall effect due to medium size of particles. And finally, suspension particles. Here also there is no Tyndall effect due to large size of particles. Here reflection of light occurs. Now in the process of filtration, in the case of true solution, solute particles cannot be separated from medium and collided particles also cannot be separated from medium in solvent. Whereas suspension, in the process of filtration, the solute particles can easily separated from medium or solvent. In the case of undisturbed position, the solute particles in true solution do not settle down. So the true solution is stable. And same undisturbed position, the solute particles in colloidal solution do not settle down. So colloidal solution is also stable. In the case of suspension, when undisturbed position, the solute particles in the suspension, the solute particles can easily settle down. So suspension is completely unstable, whereas true solution, colloidal solution are stable. Now I am going to explain the properties of mixture and compound with the help of some activities. So I have taken iron filings and sulfur powder. Both are grinded in one particular beaker and heated. We will get FES. FES is nothing but compound. So we have taken Fe plus S is the mixture and FES compound. I am going to introduce magnet. If you can roll the magnet towards the mixture, it attracts iron filings in the mixture, whereas in the compound nothing will be attracted. So we can say that the constituents of a mixture can be separated by physical means but not that of a compound. And I have introduced a carbon disulfide solution. So whenever we can drop mixture towards carbon disulfide, then sulfur can easily dissolve. Carbon disulfide solution, iron cannot dissolve. So we can easily separate. But in the case of compound, nothing will dissolve. So we can say that the components of a mixture can be separated by physical means but not that of a compound. Now we can focus on separating the components of mixture. we are having so many separating techniques. First of all, I have taken the mixture of salt and water. How we can separate salt from water? So through evaporation we can easily separate salt and water. So what is salt? Salt is non-volatile substance, whereas water is a volatile substance. What is a volatile substance? Which can evaporate at normal temperature. So by giving heat, water can easily evaporate from salt. That's why through evaporation process we can easily separate salt from water. So these images are separation of salt from water. These visuals are separation of salt from water through evaporation method. Next, separating the mixture of two immiscible liquid. So with the help of separating funnel. Immiscible liquid means those who will not be mixed in a single phase. Once again, immiscible liquid, those which will not be mixed in a single phase. Oil plus water, benzene plus water. So these all are the best examples of immiscible liquids. Now I am going to explain how the two immiscible liquids can be separated through separating funnel. Let us try to separate benzene from water using a separating funnel. Pour the mixture of benzene and water in separating funnel. Let it stand undisturbed for some time so that separate layers of benzene and water are formed due to different densities. Open the stopcock of separating funnel and pour out the lower layer of water carefully. And close the stopcock of the separating funnel as the oil reaches, benzene reaches the stopcock. This is the process in the separating funnel where two immiscible liquids separated. Of course, not only benzene and water, we can separate oil and water also. Now I am going to separate another mixture, that is salt and camphor, through the process of sublimation, whereas salt is non-volatile sublimable substance, whereas camphor volatile sublimable substance. What is the sublimation process? There are process which can be converted from solid to gases by giving heat. Now, in the process of activity, of course lab activity, take the mixture of camphor salt in a china dish. By giving heat, solid camphor can be converted into vapor of camphor. So camphor evapors. After cooling, the vapors of camphor again deposited at the walls of container. This is the sublimation process where volatile sublimable substance can be separated from non-volatile sublimable substance. We have separated camphor from salt. This is called sublimation process. And next class we will discuss dispersion phase and dispersion medium in colloidal solution and some more separating techniques. Until then, have a nice day. Thank you.